April 1945. A German soldier crouches in a bombed-out apartment building in Berlin, positioned behind a concrete wall 3 meters from a stairwell where Soviet infantry are advancing floor by floor. Direct engagement would require exposing himself to automatic weapons fire from multiple positions. Retreat would abandon the defensive line. He lifts his Sturmgewehr 44 assault rifle, fitted with a curved barrel extension protruding at a 30-degree angle from the weapon's muzzle. The attachment adds approximately 300 millimeters to the rifle's length and weighs an additional 1.4 kilograms. A prismatic periscope sight mounted above the curve allows him to observe the target area without exposing his head or body beyond the wall's edge. He aims at the stairwell reflection in the periscope and fires a 3-round burst. The bullets travel through the curved barrel, exit at an angle, and strike the stairwell wall. Fragments and ricochets wounded 1 Soviet soldier. The German soldier fires again. The barrel's rifling, already compromised by the extreme curvature, degrades further with each shot. After approximately 20 rounds, the barrel splits along a stress fracture near the curve's apex. The weapon is rendered inoperable. The attachment that allowed him to fire around corners lasted fewer than 3 minutes of actual combat use. It was called the Krummlauf, and it represented one of the most technically ambitious and operationally problematic weapon modifications attempted by any combatant during World War II. The German military in late 1944 faced an urban warfare problem that was geometric and tactical. Street fighting in Stalingrad, Budapest, and eventually German cities themselves demonstrated that conventional infantry weapons were poorly suited to building-to-building combat. Soldiers needed to engage enemies around corners, through doorways, and up stairwells without exposing themselves to return fire. Standard tactics required either exposing the shooter to enemy observation or using indirect fire weapons like grenades, which were limited in supply and ineffective against dispersed targets. Existing solutions were inadequate. Firing from the hip around corners sacrificed accuracy entirely. Mirror systems allowed observation but not aimed fire. What German infantry doctrine required was a weapon that could deliver aimed, controlled fire at targets not in the shooter's direct line of sight, that maintained sufficient accuracy to hit man-sized targets at close range, and that could be operated by standard infantry without extensive training. The engineering challenge was forcing a rifle bullet through a curved barrel without destroying the barrel, the bullet, or both. Development began in 1943 at the Waffenamt research facility under engineers whose names remain largely undocumented. The fundamental problem was that rifle bullets travel in straight lines and resist lateral deflection. Forcing a bullet through a curve subjects it to extreme centrifugal forces that can cause fragmentation, tumbling, or jacket separation. The barrel itself must withstand not only standard firing pressures of approximately 3,800 atmospheres, but also lateral stresses from the bullet's resistance to directional change. Standard barrel steel could not tolerate these combined stresses for more than a few shots before cracking. The solution involved accepting that the barrel would be expendable and designing the curve to minimize stress concentration while maximizing bullet survival through the deflection. The Krummlauf came in several variants, with curve angles ranging from 30 degrees to 90 degrees. The most common version, the Krummlauf 30, bent the barrel 30 degrees from the bore axis. The device consisted of a curved barrel extension that attached to the muzzle of the STG-44 assault rifle. The curve was not a simple bend, but a carefully calculated progressive arc designed to minimize stress concentration. Internal rifling continued through the curve, though the lands and grooves were progressively shallower toward the exit to reduce bullet deformation. The barrel extension included approximately 30 gas ports drilled along the outer curve to vent propellant gases and reduce pressure. This reduced muzzle velocity from the STG-44's standard 685 meters per second to approximately 300 meters per second at the Krummlauf's exit. The dramatic velocity loss limited the effective range to perhaps 20 meters, which was acceptable for the close-quarters urban combat the weapon was designed for. The periscope sight was mounted on a bracket above the curve, using mirrors to present the shooter with an image of the target area around the corner. The sight was not precisely calibrated and required the shooter to estimate holdover and windage based on experience. Manufacturing the Krummlauf required specialized equipment and precise heat treatment to prevent immediate failure. The barrel blank was bent using hydraulic presses while heated to approximately 900 degrees Celsius. After forming, the barrel was heat-treated to restore some structural integrity. Then the interior was reamed and rifled. The gas ports were drilled and the mounting threads were cut. Each unit required approximately 18 hours of machining time, expensive by wartime standards. Quality control was inconsistent. Some Krummlaufs failed after fewer than 10 rounds. Others lasted perhaps 40 to 50 rounds before catastrophic failure. The barrel's useful life was inversely proportional to the rate of fire. Rapid firing generated heat that accelerated stress fracture propagation. Operational deployment began in late 1944, primarily on the Eastern Front, where urban combat was most intense. Initial user reports were negative. The device was heavy and unbalanced, making the already cumbersome STG-44 difficult to handle in confined spaces. The reduced muzzle velocity meant bullets lacked penetration against even light cover. The periscope sight was difficult to use in low light and fogged easily in cold or humid conditions. Most critically, the barrel's limited lifespan meant the weapon could not sustain fire in extended engagements. Soldiers reported that Krummlaufs frequently failed at critical moments, leaving them armed with a disabled rifle, requiring field disassembly to remove the attachment and restore normal function. This process took approximately 2 minutes under ideal conditions, longer under combat stress. Training emphasized fire discipline and target selection. Soldiers were instructed to fire only single shots or very short bursts to allow the barrel to cool between engagements and to expect barrel failure after 20 to 30 rounds. These limitations made the Krummlauf suitable only for very specific tactical situations, engaging known enemy positions from fixed defensive positions where the shooter could not be flagged and where engagement duration was expected to be brief. In practice, these conditions rarely aligned. Urban combat was fluid, enemy positions were often unknown until contact occurred, and engagements frequently required sustained fire. The Krummlauf's tactical niche was so narrow that most units issued the device used it sparingly or not at all. A variant was developed for armored vehicles, designated the Krummlauf P for Panzer. This version had a sharper curve, typically 45 to 90 degrees, and was intended to allow tank crews to engage infantry in the vehicle's dead zones without exposing themselves through open hatches. The Krummlauf P shared the same fundamental limitations as the infantry version, but added complications specific to armored warfare. The attachment had to be installed and removed from inside the vehicle, a difficult task in combat. Barrel life was even shorter than the infantry version due to the more extreme curve. Few were produced, and fewer still saw combat use. Most tank crews preferred to rely on whole machine guns and supporting infantry rather than risk weapon failure at close range. Comparison with Allied weapons development reveals no equivalent attempts. American, British, and Soviet forces addressed the same tactical problem through different means. The Americans emphasized grenade launchers and submachine gun volume of fire. The British used extensive use of indirect fire mortars for close support. The Soviets relied on overwhelming infantry numbers and accepted higher casualties in close combat. None attempted to develop a curved-barreled weapon, likely recognizing the engineering challenges as insurmountable given wartime manufacturing constraints. The Krummlauf represented German engineering pushed beyond practical limits by tactical desperation. Production numbers are difficult to establish precisely. Estimates suggest between 10,000 and 15,000 Krummlaufs were manufactured in various configurations between 1944 and 1945. Most were issued to units on the Eastern Front, where urban combat was most intense. Captured examples were analyzed by Allied intelligence, who concluded the device was interesting from an engineering perspective, but tactically useless given its limitations. Post-war analysis confirmed this assessment. No military subsequently adopted curved-barreled weapons for standard issue. Experimental development continued in various nations during the Cold War, primarily for specialized applications like firing from armored vehicles, but fundamental material science limitations prevented practical deployment. The technical failure of the Krummlauf derived from attempting to violate physical principles that could not be overcome with available metallurgy and manufacturing techniques. Rifle bullets must travel in relatively straight paths to remain stable and effective. Barrels must be straight or very gently curved to survive the stresses of firing. Attempting to combine a functional rifle with a sharp curve required compromises that rendered the resulting weapon unreliable for sustained use. The device worked in the sense that it could fire bullets around corners. It failed in the sense that it could not do so reliably enough to be tactically useful in actual combat conditions. The German soldier in Berlin who fired 20 rounds through his Krummlauf before barrel failure never knew whether his shots had any tactical effect. The weapon's short barrel life meant he could not sustain suppressive fire. The reduced velocity meant his bullets lacked penetration. The periscope sight meant he could not accurately engage specific targets. The attachment that promised to solve the corner problem created more problems than it solved, and the soldier who survived the weapon's failure likely abandoned it and reverted to conventional tactics for the remainder of the engagement. The Krummlauf existed at the intersection of engineering ingenuity and tactical desperation, a weapon that worked precisely well enough to be manufactured, but not well enough to be useful.